In this lecture, we'll see different data types possible in the C program. So here, like we have a different possibilities of values in maths. So there are different variables to demonstrate represent those. The first one is integer. So integer, if you see, it starts from a negative value and all the way go to positive value. So this is a range. So if you simply use int in your C program, it means it's a signed integer. So there is a sign here. Float is to represent the decimals. Character is to represent a character, as well as it will represent the number from 0 to 55. Yeah. And then double is an extension of the float, where it is 8 bytes and there is a enhanced range. Yeah. So now in code blocks, we'll see the different sizes, how we can use a code block to print different sizes. Yeah. So this is the code block, and I just clean the code, or I'll just keep it as it is instead of writing and wasting time. So here we are making use of one of the built-in function called size of operator. Yeah, size of, it's not an operator, size of function. So when I pass size of and the data type name itself, okay, or I can also pass the variable C of type character. Let's see what it builds, yeah, what it returns. So you can see size of character is just 1 byte. Yeah, that's what we saw in the previous slide. So next we'll see the size of integer, and here instead of variable, I'll just write the data type int. So now if we see the size of int is 4. Yeah. What is the size of float? As we see, this is also 4. So yeah. So you can see here the size of float is also 4. So in this way, we can make use of the size of built-in function to get the size. In future, I mean, in the next lessons, if we see the arrays, there we can make use of the size of function efficiently. Yeah. So this is about the variable sizes and how to use the size of operator. Yeah. Next, we'll see the ranges. So we'll take a simple variable, simple data type. Yeah. This is a range function or a range demonstration. I would like to take unsigned character because it stretches from 0 to 255. So I'll name it A. And now what I'll do, I'll write A equal to 255. This is what I know it is possible, maximum possible value. Character A equal to D. Return 0. Let's compile and see what it prints. Printing 255. Now, here comes a question. What happens if I write 256 here? Yeah, I'll write +1. So what we know is range 0 to 255. Yeah, now I did A equal to 255 plus 1. Let's compile it, build it. See, you're seeing 0. 0. Let's take one more example. Add 2, then it makes sense why it was printing 0. You see, it's printing 1. Yeah, because it starts to roll over after 255. After 255, 0, then 1. That's why if you add 2, you're getting 1 here. Yeah. When we added 1, we were getting 0 because it's rolling over. So what is the significance of this exercise is when you're defining something or when you want to use a variable to capture a data which you think cannot fit in 8 bytes. Say something has a range of 0 to 1000. I think we should not be using character, unsigned character to store it, though it takes 1 byte. So we should not. This is a takeaway from this lesson. What we saw previously is the range of the integers, range of char. And what happens if we roll over the range. So it will only go to 0. Now we'll see what happens if we use different type of integers, different type of data types to do the mathematics. Do the arithmetic operation. I'll define two integers. Here what I'm trying to do is I'm trying to add two integers and capture two float and capture it in an integer. Let's see what happens to the result. So b is equal to 12.2 and then I say c equal to, which is integer a plus b. So what we expect, what we know for sure is c, which is integer, cannot have a float value, correct? So let's see what it prints now. I'll compile and do this. See, it's printing just plain 27 and it has successfully ignored these decimals. Okay, but this is not an intention. This is a very bad arithmetic, correct? So we cannot miss out on decimals. So now a better way to do is I'll just change it to float. So now I'm making a better choice of data types for my variables. So here I'll just write f and then let's see. Let's print it successfully something 27.7001. Not entirely sure why there is 01 here. Maybe if I had int here and float here, it would have given me a 0 because it's trying to print only the floating part of c, which is 0. So this is not a correct way. You can either use d when you have integer here, or use f, have float here. Yeah. So then it can also happen that I have two integers and both integers, say this is 15 and 2. Yeah. Instead of addition, I'll do division. So now the answer is 7.5. But let's see, I'm thinking it will print only 7. It will ignore the decimal part. You can see it has ignored the decimal part. That's because first it has divided both 7.5. Both are integers and has converted the result into integer and then assigned to this one. Because when two operands are involved, then it will try to take the result into a biggest data type. Yeah, if there is an integer and char, then the resultant will become character. So better way to do this is make float here, and this is what I call it. This is what is called typecasting. You're typecasting an integer to float for your need, right? So now compile it, build it. You can see 7.5 is returned here. Yeah, though these are integers, without typecasting you were getting 7, with typecasting you were getting 7.5, the exact result. So this is the use of typecasting. Yeah, you can making use of typecasting, we can get the accurate results.